Let's start today's session. I am Nisha Varghese. I am a PhD scholar from IIT Madras. I am here to take this interactive live session on week 1 videos for the subject, NPTEL subject, image signal processing. So I am hoping that, yes, it is actually recording and the link will be shared with you. Okay, so I'm hoping that this live session will help you to get a clear idea about the topics discussed in the last week, and it will be helpful for you to do the assignments. And for the NSEM also, it will be very helpful because we'll discuss some of the problems, some of the theory and problem on this topic. So since it is a programming based course, you have to do the programming assignment. So try to avoid questions related to the implementation of the assignment. The theory part we can discuss. So the implementation you have to try yourself. Okay. I'll quickly go start the presentation. So first I'll just recap the week 1 topics, and then we'll cover some of the questions on those topics, and then after that you can ask your doubt. Okay. The first topic discussed in week 1 was applications of image processing. So professor already discussed these topics. So first one is astronomical imaging. For that, deblurring and denoising are done as the application of image processing. Then comes consumer camera. There we have different applications. So I'll show some of the pictures so that it will be understandable to you. Okay, then comes robotics. For robotics, main thing is to find the depth map. Then comes remote sensing. There segmentation is the main application. Then comes biometrics. Then medical imaging, surveillance, digital heritage, underwater imaging, and industrial applications. These points are already discussed in the week 1 video. Okay. So in consumer camera, so the first topic is autofocusing. So autofocusing is what? So some of the portions in the world will be focused automatically inside the camera. So that is done with the help of an image processing, because we have to detect which are the objects. Actually, we have to detect on what object we are interested. So that object should be focused inside the camera. So that thing is done using image processing. Then comes HDR imaging. HDR imaging means HDR is high dynamic range image. So if we have an image like this, the first image, it is having darker areas here and here. So the portions on those darker areas are not visible, right? And at the bottom image, we have some of the saturated pixels are here. So those portions are all, uh, so the intensity at those portions are not visible in the images. So our aim is to convert that LDR image to HDR image, so that the black portions, so in the HDR images, we can see those areas that were hidden in the LDR images. Okay. Then comes low light photography. In low light photography, as professor already discussed, photo noise is the main issue. So that topic will cover later. Then comes motion deblurring. For motion deblurring, if the camera is moving or the object on the world is moving, there will be blur inside the image. As you can see in the red box, we have some blur inside that patch, right? So we have to do the motion deblurring so that that portion will be deblurred. So the portion will be clear. So this is one of the applications in consumer camera. Then comes image mosaicing. Image mosaicing is actually connecting different images. Say if we have 5 images captured with the same camera, but those 5 images are a part of the same scene but different images. So we have to stitch those images such that the field of view is large. So we can't just do a stitching like we will serially overlap those images one by one, but that won't give the perfect scene. So we have to do some transformations on every image, and we have to do some do some transformation on the overlapped region. So that is the aim of image mosaic. So image mosaicing is used to increase the field of view. Okay, then comes image sharpening. That one you already know. Then comes biometrics. So biometrics is like from the fingerprints or iris or from face, people will be identified. That is so image processing. So application image processing used for that application. Then comes robotics. In the case of robotics, we have camera with us, and we'll capture some images. And the main application in robotics is the depth map, finding the depth map. Depth map is actually found out from one image or two images. So from two images, the depth map can be found out using stereo imaging. Okay, so from one image itself, we can find the depth map. So here in the first image, we can see that this portion is actually very near to the camera, right? And the other portion, that door portion, is very far away from the camera. So that portion should be marked as a red portion. Red portion means that it is far away from the camera, and this portion is very near to the camera. So that portion will be colored as blue. So if you are giving an input like this, the first image, you will get a depth map like the second image. So that is one of the aim in robotics. And for the second set of images, if we have two stereo images. So stereo images is the images captured from our eye. So the first image is the left image, and the second image is the right image, and using those two images we'll find the depth. So here also depth map will contain some intensities. So this lamp is situated near to the camera, so a white color is given to the depth map. And for the back portions, this wall portions and all will be given a dark color in the depth map. So this is the depth map from single image or from two images. Then the application includes surveillance. For surveillance, object detection and tracking is one of the application. So as you can see, surveillance cameras will be situated on the roads, and cars will be detected from the video. And along with that, motion deblurring is used to detect number plate also. So due to the movement of the car, number plate and number will be blurred, motion blurred. Then that will be deblurred to the numbers. So these are some applications of image processing. Then comes astronomical imaging. There we have deblurring and denoising of the images. So the first set of images are having some blurriness and noise. So we have to denoise it and deblur it to get a clean image. So this is one of the application. Then comes medical imaging. So medical imaging, it can be used to detect from the images. It can be used to detect some malignant tissues, or it can be used to diagnose some diseases. Okay, so, and the next application is underwater imaging. So when we capture images from underwater, some color distortion will be there. So that should be restored to the a good picture. So that is known as underwater image enhancement. So these are applications of image processing. And the next topic is resolution. So in the video, it is already discussed that there are actually three types of resolution: spatial resolution, gray level resolution, and temporal resolution. Okay, so spatial resolution means that for a particular area, for a particular unit area, it so in the first image, just so in the marked that blue area, how many pixels will be there? So it will be around a 12 by 12 pixel area will be there, right? But in the second image, for the same area, number of pixels will be high, right? And for the third image, for the in the in this in this area, the number of pixels will be very high. So we can say that spatial resolution is increased when the number of pixels inside a particular area will be increased. So actually we prefer, so visually pleasing image is the third one, right? So spatial resolution should be increased for visually pleasing images. But we have to store more number of pixels in the case of high spatial resolution images. So there will be huge memory requirement for higher spatial resolution images. Okay, so we can say that if a particular area is having higher number of pixels, we can say that its spatial resolution is higher. Then the next resolution is gray level resolution. So just look into the third picture. So it is a 4 gray level image. It means that the image has only 4 gray colors: black color, white color, dark gray color, and a light gray color. So those 4 gray colors are there in the third image. But it is not visually pleasing, right? Some contour will be shown here, right? So for visually pleasing results, we have to introduce more more number of gray colors inside the picture, right? So in the first picture, we have 256 gray levels. So that picture will be having black color, white color, and in between a number of gray colors will be there in the first picture. So that will be visually more pleasing. So gray level resolution is high when the number of gray levels inside the image is very high. Okay. But we have to store the image, right? So if we are using more number of gray levels, so we have to use more number of bits to represent a particular gray level. So for each pixel, we have to use more number of bits. So if you are using more number of bits, we have to use more memory, right? So as we increase gray level resolution also, the number of the memory requirement will be higher. Then the third resolution is temporal resolution. Temporal resolution is what? If you are using a 30 frames per second video, if you are capturing with this rate, in 1 second we'll capture how many frames? 30 frames. If you are capturing 60 frames per second, in 1 second we'll capture 60 frames, right? So in the second case is having higher temporal resolution. That is, in 1 second we'll capture 60 frames back to back. So it will be having a large number of frames, and along with that memory requirement is also high for higher temporal resolution images. Okay, so we have three resolutions: spatial resolution, gray level resolution, and temporal resolution. Spatial resolution relates to the number of pixels in a particular area, but gray level resolution relates to the number of gray levels in a particular image. Third one is temporal resolution, relates to the number of frames for a fixed time. Okay, then so we'll go to some maths. So let's take the first image. How many pixels are there? The first image, 6 by 6, 36 pixels. So the first image has 36 pixels, but the first image has only two colors, right? What are the colors? White and black. So the picture has only white color or a black color. So we can store this image using 0 for black and 1 for white. Okay, so the first pixel value will be 1, second pixel value will be 1, and this pixel value will be 0, like that. So we have 36 pixels, and for each pixel we'll use 1 bit to represent the image, right? So one bit is used to represent 1 pixel. Okay, so for storing 36 bits, we will use how many pixels? For storing 36 pixels, we'll use how many bits? 36 bits will be used to represent the whole image. Okay, so this type of image is known as 1 bit image. This image is known as 1 bit image. Why? 1 bit is used to represent 1 pixel. Then take the next uh, image. Here, the number of pixels is 36 pixels. But we have more number of gray colors inside the picture, right? What are the colors? White color, black color, dark gray color, and light gray color. 4 colors are there. So we can't use a single 1 or 0. If you are using a 1 for white and 0 for black, then we can't give any value to dark gray and light gray, right? So we have to use more number of bits to represent 1 pixel. So here we have 4 colors. Then how many bits we'll use? 2 bits we can use, right? So for black, we will use 0 0. Then for white, we will use 1 1. Then for dark gray, we will use 0 1. Light gray, we will use 1 0. Okay. So for black 0 0, so we have 2 bits for every pixel. We have 36 pixels in total. Then how many bits should be used to represent this image? 36 pixels into 2 bits. We'll have 72 bits to store this one single image. Okay, so in the previous case, the same number of pixels are there, but the number of colors, number of gray levels inside that image was only 2. But here it is 4. So the number of bits to store the image is increased here. Okay. So this image, the first image is known as 1 bit image. This image is known as what? It is a 2 bit image. Okay. Because 1 pixel is represented using 2 bits. Because it has 4 colors inside that. Okay. So, I'll go through one question. You can answer it using poll. So if you are using laptop, you can just go through that right bottom corner, activities tab. There you can see poll. So I have launched the poll. Can anyone see the poll?
Yes, ma'am.
Okay. So just answer that poll. An X bit image has 512 gray levels. So what is the value of X? So I have already said first one was a 1 bit image, second one was a 2 bit image. Okay.
16, ma'am.
The answer in poll only. We can discuss after that. Okay. Uh, so in the previous slide, it was first image has. Do not say answer here. Just click the answers.
I'm connected to phone, so I don't think I have that option.
Oh, okay, okay. Okay, so in phone, some activities are there. Some activity tab is there. Anyone is using it?
No, ma'am.
Yes,
I
ma'am.
think
There is also activities in the phone also, ma'am.
Yeah, it's there in the phone as well.
Okay. Just try. Otherwise, it is okay. We can discuss. The aim is
oh,
to get some idea. That's all. Okay.
Sorry, ma'am. Where can I get the access for these questions, ma'am? I'm not able to see them.
Okay.
I'm logged into my phone.
Okay. Okay. Can you see the presentation?
Yes, ma'am.
Okay. Then, what's your doubt?
Is there a separate window where I access these questions, or
Okay. Okay.
I?
So this link will be shared with you. The link of this presentation as well as the YouTube link. Okay.
Okay, sure.
So is someone attempting the question, or shall I end the poll?
I entered,
Ma'am,
ma'am.
Okay. 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 I can see here. Okay. I'll end the poll now. Then we can
uh,
discuss. Okay.
sorry, ma'am. The
Uh,
coding questions, they get tougher. Like when I last time took the course, like there wasn't a direct guide. Will there be a guide, for
uh.
example, how to solve those coding questions as they get tougher, ma'am? Like this time.
Oh, last time it was you took the course.
Yes, ma'am. But actually, what happened was
Uh,
last time after I took the course
mm,
in middle, the coding questions they were a bit advanced, so I didn't get like the idea. So when I thought if somebody was there to answer those like coding questions, it would have been better. Like I thought if there would
okay.
be sessions to cover this time, like that was my doubt.
Okay. Okay. So after discussing some of the, I have only 7 questions. After that, we can discuss how to do the assignment. We can discuss if you have any doubt. Okay. But
Okay, sure.
programming you have to do by yourself.
Yes,
Okay.
ma'am. Yes, ma'am. Yes,
Okay.
ma'am. Yes, ma'am.
Okay. Okay. So I'll end the poll. Okay. So the answer is ah, hello. Okay. So in the previous slide, I have explained like if you have two colors, it is a 1 bit image, right? And it is a 4 color. If it is a 4 color, it is a 2 bit image. And if we are representing it using 3 bit, if you are representing it using 3 bit, how many colors will be there? 8 colors. How? 0000001, etc. 111, right? So 8 colors will be there for 3 bit image. So if we have x bit, how many colors will be there? 2 raised to x.
X.
Okay, so what would be x? 2 raised to x is equal to 512. So what would be x? 9. Right. Any doubts? So we can go through the next topic, short noise. So short noise explained for addressing what that low light noise. Okay, so short noise is a signal dependent noise, and it is due to the arrival of photon. It is due to the uncertainty of the arrival of photon to the image sensor. So that arrival or the counting problems can be represented using a Poisson distribution. So, the first question is, so what is the expression for the probability density function of a Poisson distribution? So I'll launch the question. So somebody can answer. I already launched the poll. So what is the probability density function of the Poisson distribution? Okay. So these type of questions will come in the NSEM. The question will be tougher, obviously. It is a straight question. It is a probability distribution of a Poisson distribution. Okay. So I'll end the poll now. So the answer is first one. F of x is equal to e raised to minus lambda, lambda raised to x by x factorial. So what does this PDF indicates? So if we know the average number of photons arrived, if it is lambda, say in the bright light condition, lambda will be very high, right? So average number of photons uh, arrived on the sensor plane will be very high. But in the case of low light case, lambda will be less. So if we know lambda, if we know the average number of photons arrived on the sensor plane, we can represent this probability distribution, where x is the number of photons arrived. Okay, so this PDF indicates the probability that the number of photons arrived is x, given that the average number of photons arrived on the sensor plane is lambda. So this is the meaning of this probability distribution. Then using this probability distribution, so I'll write the probability distribution here. F of x is equal to e raised to minus lambda, lambda raised to x by x factorial. So using this probability distribution, in the videos, mean in the video, mean value of this probability distribution and variance value were found out, right? Using what? Characteristics function. Characteristics function is denoted using phi of s. So here you are given three statements. Characteristics function is given by phi of s is equal to expectation of e raised to minus sx. Then its mean value is after finding the first derivative of phi of s, just give s is equal to 0. That will give mean. And the third statement is after finding the second derivative, and if you are giving s equal to 0, that will give variance. So these are three statements, and you have to select which of the statements are correct. Okay, so question 3, I have released the question 3. So answers are all the 3 are correct, only 2 and 3 are correct, only 2 can answer. So the characteristics function is used to represent completely a particular distribution. So if we know the characteristics function of a particular probability distribution, we can straight away find its mean and variance by finding its first derivative and second derivative. So it is the usage of that characteristics function. So it is very important in the case of this probability theory. Okay, only one person voted the poll. Okay, someone raised the hand. Okay, you can answer in chat box also. Okay, if you can't access the poll. Okay, the answer is first. So we'll go through one by one. So the first statement is characteristics function is given by phi f is equal to expectation of e raised to minus sx. Whether that is correct? Actually, no. Actual equation of characteristics function is expectation of e raised to sx. Okay, not a minus there. Then the next statement is phi dash s at s equal to 0 is mean. That is true. Okay. Then the third one is if you are finding the second derivative and if you are giving s equal to 0 there, you'll get variance. Whether that is correct? So this is wrong. This is also wrong. Okay. Uh, you'll get the second moment only. Okay. For variance, you have to find out what variance is. Second moment minus mean square. Okay. So the third function will give only the second moment, and we have to find the difference between m2 second moment and mean square to get variance. So only the second option is correct. So the answer is C. Then we'll go to next question, question 4. So so this portion is already covered. The distribution of Poisson distribution e raised to minus lambda, lambda raised to x by x factorial. And in the videos, it was already discussed that the of uncertainty of the arriving photon is what lambda mean plus or minus variance, a standard deviation. Okay, and it was derived that mean of this distribution is what lambda, and variance of the distribution is also lambda. Then the uncertainty will be what? Mean plus or minus root lambda. Mean plus or minus standard deviation. So what does it mean? That is, the photon's arrival can be from lambda minus root lambda to lambda plus root lambda. Okay. So, so the question here is, on the average, number of photons gathered is 64. Then what would be the range of uncertainty of gathered photons? Minimum and maximum values of the gathered photons. So can you answer that? I launched the poll. So the average number of photons is 64. So what is given? And uncertainty I have already written here. Okay, so the average number of photons is 64 there. Okay. Okay, I'll end the poll. Okay, so lambda is 64. Then root lambda, standard deviation will be 8. Then the uncertainty will be 64 minus 8. That is 56 to 64 plus 8, 72. So there can be an uncertainty from 56 to 72 for the arrival of photons. The answer is B. Okay, so the thing is that if there is a bright light, the average value lambda will be high. So it is 10,000. Okay, then the uncertainty is also will be very low. Like it will vary from 10,000 minus 100 is very the deviation from 10,000 is very low, right? But in the case of low light, if you have a low light, say it is having only 100 lambda. So average number of photons will be 100 for low light. Then its uncertainty will be what? 90 to 110. So the noise content will be more in the case of low light case. But in the bright light case, it is negligible. So that is why we are getting short noise in the case of low light. Okay, so this is already explained. Then in question 5, which of the statements are true? Short noise can be reduced by increasing the exposure time. If the exposure time is increased, there can be a chance of motion blur. Third statement is temporal resolution will be reduced if the exposure time is increased. So which of the statements are true? Question 5 I have already launched. So for the next time, if you are taking laptop, you can answer this poll. So okay. Okay, so the first statement I'll explain. Short noise can be reduced by increasing the exposure time. So short noise is the problem of low light condition, right? So if you are increasing the exposure time, more light will be falling on the sensor plate. So that will reduce the short noise. So the first statement is true. And the second option is, if the exposure time is increased, there can be a chance of motion blur. Means if your shutter is open for a particular time, like if it is open for 1 second, okay, actually your exposure time is increased to reduce the short noise, but at the same time, if you are shaking your camera during the exposure time, there can be a chance of motion blur, right? So so the second option is also correct. Then the third portion is temporal resolution will be reduced if the exposure time is increased. So what does that mean? Temporal resolution is what? If the resolution is higher means more number of frames are captured in a particular time. So if you are increasing the exposure time, number of frames captured is less. So the temporal resolution will be reduced. So that option is also correct. So the answer is A, all the three. Then the next question. Okay, then comes geometric transformation. That is an important topic. And the assignments are based on this topic. So we have 3 translations covered in the last week videos. Translation, rotation, scaling. So you know the equations and all right. So the question is, if the source coordinates are, I'll launch the question first. Okay, the source coordinates are x's, y's. Source coordinates are given 100, 200. Okay. Find the target coordinates. If there are 3 operations done back to back. First one is translation with x is translated to with a translation value 100 and y is also translated to a position with translation value 100. So first x's y's is translated to some other coordinate, not 100 100. Translation value is 100 100. Okay, Then comes in plane rotation for an angle theta 360 degree. Then a scaling will be done with a scaling factor 0.1. So what would be the target coordinate? So I have released the poll. You can answer. Okay. So 100, 200. First translation, second rotation, third scaling. Okay, only one vote is there in polls. Okay, so source coordinate is 100, 200. First it is translated to some other coordinate using a translation value 100. So it will be 100, 200. So xs plus tx 100. Then yt xt1 yt1. First translation. Okay, will be 200, 300. Then next translation is what? Rotation. So xt2 yt2 will be angle 200, 200, 300 here. So cos theta 0, sin theta, sorry, cos theta 1, so you'll get same coordinate, right? 200, 300. Then comes the scaling factor. So xt3 yt3 will be 0.1, 0, 0, 0.1, 200, 300. So you'll get 20, 30. So the answer is C. Okay. And the next problem is last topic discussed was bilinear interpolation. So here what are you doing actually? You will translate from target point to source point. Right. In order to avoid holes, you will find a transformation from target coordinates to source coordinates. Then after transforming, you will get one coordinate value xf yf that won't be an integer value. So say it is 2.5, 1.5. So you can't map that there is no intensity value at that decimal coordinate, right? So you have to find out four neighboring pixel coordinates. So they will be 2.5, 1.5. So the neighbors will be 2, 1, here 2, 2, here 3, 1, here 3, 2. Then using the intensities at those neighboring position, you will find the intensity at the target position. How? Using this formula. So for that you'll have to find out A and B first. So A and B can be found out using this distance from the neighbor to the center pixel. Okay, so this one you have already done in the assignments. So one question is there. In a target to source transformation, the source coordinates calculated are 2.5, 1.2. 2.5 and 1.2 is the position you got from calculation. Then the intensities in the four neighbors of x's are given in red color. So this neighbor has 100 value, this neighbor has 200, here 200, here 100. Then find the intensity at the target coordinate. Find the intensity at the target coordinate. So if you want to do by yourself, just take a pen and paper and do. Okay, so the intensity is 2.5, 1.2. You have to find out the intensity at the target coordinate. IT. IT will be, so you have to first find A and B. A is the distance between this left topmost neighbor and the point, and B is this distance between this 2.1 and 2.5 and 1.2. Okay, I have already launched the poll. We can answer that. Okay, so A will be what? A will be what? 2.5. B will be 0.2. Right. So the intensity at the target position will be 1 minus A into, so 0.5 into 1 minus B into 0.8 into the intensity at the corner 100 plus then 1 minus A into B into this corner 200 plus A into 1 minus B into the bottom corner, then A into B into the last corner. So you'll get 120. Okay, so the answer is B. So for the first week, the questions are very simple. So the question answer session is over now. If you have any doubt, you can ask. So regularly watch the videos, otherwise the topics will be, the next portions will be tougher than the first week. So if you're getting what, if you're getting a concept, initial concept, it will be helpful for you. So try to cover week 1 videos fast and do the assignments. Okay, so if you have any doubt, you can ask. So for the assignment, you are given what, one source image and one target image you have to find out. So translation is given in the first question, right? So you have to translate source to target. Okay. So you have source image here, you have target image here. So you have to translate the source to target. You have only source intensities with you. So this thing, after extracting the image to the code, you will get the intensities at each position, right? Your aim is to translate the pixel coordinates. Okay, so in order to avoid holes, you will first take one target coordinate xt yt. So you'll first take this corner position, right? So you will take 1 1. Then you know the translation. Translation, you know what? Xt yt is equal to xs ys plus tx ty. Tx ty. So you have to translate from source to target, but here you have to translate from target to source. So you will write the equation the opposite form. How? Xs y is equal to xt minus tx and yt minus ty. Then this translation you apply on every target position. So you'll get some x's y's, and if it is outside the image area, that is if it is negative or if it is more than the image area, you will omit those values. Otherwise, if x's y's is a decimal point value like 2.5, 1.2, what you will do? You will do the bilinear interpolation. So using bilinear interpolation, you have source intensities with you at the corner points. So you will map those points to get the target intensity value IT. So you have that equation with you. So this IT equation, bilinear IT equation, that is 1 minus A into 1 minus B, that you have to write in the code. Then you have to find this transformation. So this transformation also you have to find. That also you have to write in the code. Okay. So that's all for translation, and for rotation it is similar to this translation, but the thing is that you have cos theta, sin theta, minus sin theta, cos theta values. So where xt yt is equal to cos theta, sin theta, minus sin theta, cos theta, x's y's. So either you find an equation for x's y's equal to some matrix into xt yt. So there will be cos and sine here in A, but some sign will be different. Okay. So just find that matrix. How will you find? From this equation, from the first equation, just write xt is equal to cxs plus sys. Then second equation, yt is equal to minus sxx plus cys. Then from that, just find what is x's in terms of xt and yt. Okay, from two equations, just find what is x's and y's using xt and yt. Then you will get A. Then using that A, you can straight away find x's and y's. If they are not integer values, just use bilinear transformation to find the target intensity value. So that's all. So you can use any arbitrary value of the rotation angle for that structure to be straight. Okay. Then for the third question, you have scaling. So that's also straightforward. So this is all about this week 1. And you have any doubt, you can ask on theory question or problems or assignment. So next Tuesday we'll discuss week 2 videos and problems related to the week 2 videos and the assignment related to week 2. Okay, thank you. Thank you all. You can leave.
Thank you, ma'am.
Thank you.
Hello, ma'am.
Yes, yes, yes.
Ma'am, I'm
Ah,
Vimal Raj. I have some
okay,
question, but not related to this session, ma'am. Week 1
okay,
videos.
okay,
I have
okay,
some
okay.
questions in blurring. Shall I ask now, ma'am?
Oh, yes, yes, yes.
Ma'am, I have a data sets, ma'am. From that, I
Okay.
have to identify blurred images alone. Is it possible, ma'am? How to identify blurred images alone, ma'am?
Blurred images.
Yes, ma'am.
So you have sharp images and blurred images.
Yes, ma'am. Combination of 1,000 images in a folder, ma'am, which
Okay,
was collected in real-time environment.
okay,
From that, I have to segregate only the blurred images alone, ma'am.
okay. So the sharp images are fully sharp or partially sharp? Like,
Partially sharp images.
okay, okay. So the blood content is different for every images. Means some of the images are mostly sharp, some of the images are
Yes,
blurred.
yes, ma'am.
Okay,
Also, if
so
some of the images are fully sharp images and some images are fully blurred images, ma'am.
okay,
I want to segregate a blurred images alone or a blurred portion alone, ma'am. How to
okay,
segregate?
okay. From an image, you have to get the blurred portions only.
Yes, ma'am.
Okay, so that is not a straightforward question.
Okay, ma'am.
There are blurred measure.
Okay, ma'am.
Uh, okay, okay.
Like
So
brisk and sharpness measures, ma'am.
sharpness measures
Structural
are there.
similarity index, brisk, like that.
Yes, yes. So there are sharpness measures. So did you try that on
Yes,
images?
ma'am. I tried, ma'am, but I'm getting just the values, ma'am. I don't find the blood portions, ma'am.
Okay, okay. So for a particular image, you will get some values.
Yes, ma'am. But with
Okay,
the
okay.
values, I can't find the blood portions, ma'am.
Okay, okay. So one way you can do it like you can split the image to different patches.
Okay,
Okay.
ma'am.
So for each patch, you find the sharpness measure.
Okay, ma'am.
So from that, you will get which patch has more blur. Okay.
Uh, Ma'am, my
But
question is very generic, ma'am. But instead of
uh,
finding blood portion alone,
uh,
fully blurred images, ma'am. I
uh,
how does yes, ma'am. I have 1,000 images in a data set, ma'am. Thousand
okay, okay.
images. From that, some images are like 10 to 20 images or sharp images, ma'am. I
Okay,
don't
okay.
want to select 30 images. I want
Oh,
remaining 75 images. How to remove the 25 images alone?
okay, okay. So what is the output with that sharpness measure for every image?
It's around, it varies, ma'am, because some are over brightened and some are low brightened images, ma'am.
Okay, okay. Which
So
sharpness measure did you use?
UIQM, ma'am.
UAQAM.
UIQM, underwater image quality measure, ma'am.
Okay, okay, okay. So I didn't come across this UAQM, but
Okay, ma'am.
some value you'll get right for
Yes,
every
ma'am.
image.
Yes, ma'am.
So whether that matches with the blur, like
Uh,
for more blur, you should get lesser value, right?
but what is the standard values, ma'am? If it has value, if it has one,
Uh,
it will be a sharp image. If it is zero, it will be blurred. What is the value, ma'am? How can I segregate, ma'am? I don't know
oh,
that standard value, ma'am.
UAQM value gives either 0 or 1.
No, ma'am. For example, I said zero and one.
Okay, okay.
Around 5 to 10, ma'am. Yeah, it's around 5 to 10, ma'am. For all the
Okay, okay.
images,
So
I got the
okay,
values. Yes,
okay.
ma'am.
So for five you'll get 4 blurred images, right?
No, ma'am.
Uh,
Some blurred images has 10 also, ma'am. That's why I got
okay, okay, okay.
confused, ma'am.
That is why I'm saying that it is not a straightforward question.
Okay, ma'am.
Okay, so you just try with other quality measures.
Okay,
Okay,
ma'am.
so can you just write your mail ID in the chat box?
Yeah, sure, ma'am.
Okay, I'll search and if I am finding anything, I'll let you know.
Okay, ma'am.
Okay, okay, chat box you write.
Yes, ma'am.
Okay, wait. Okay, if I'm finding any papers on it,
Uh,
I'll let you know. Okay.
Okay, I have already searched many papers, ma'am. There are methods like blur detection, blur classification, everything I have gone through once, ma'am. But I
Okay.
haven't found a proper solution, ma'am. I have even posted in a,
Quantify.
yes, ma'am.
Quantify the blur. So that is also an ongoing problem in image processing
Yes, ma'am.
because
Actually, I'm a research scholar, ma'am. I'm working in
okay,
deep blurring, but
okay, okay.
initially I'm collecting data now. But
Uh-huh.
I can't segregate that blurred images. That's why I'm waiting, ma'am.
Yes, yes, yes. Some no reference quality measure. Did you search for that?
Yes, ma'am.
No ref.
Yes, ma'am. I have searched all the non-reference metrics, ma'am, including
Yes, yes.
GLCM features also. Uh,
Yes, yes, yes.
some.
NAQE, PAQE.
Yes, ma'am. I have tried SSM,
Yes, yes,
everything,
yes.
ma'am.
Yeah, but
But
NAQ and PAQE, I have already used them, but that those methods are all not accurate actually.
yes, ma'am.
Hmm.
I have posted this same question in methods also, ma'am. In
Okay.
methods, some have answered that you can try for transformation like FFT, then you
Uh,
will, then it will be easy for me to segregate. But that's also not worth enough, ma'am. So
Okay, okay. So
I need
if
some
we are
solution.
converting to FFT, high frequency content will be less for blur images.
Yes, ma'am. They
Yes,
have
yes,
posted
yes.
the same one, but
So,
for me the all the frequencies look like same, ma'am. I don't find motion blurred or what to say clear images frequency, ma'am. Everything look like it has noises. It doesn't show
oh,
that the image has blur.
okay, okay. What would be the average value of the that F50?
uh, Average values, I don't remember, ma'am. I have